Hello, today we're going to start talking about an introduction to probability. Now, the usual starting place that we have with probability is looking at what we call sample spaces. So let's look at a couple of sample spaces. A sample space is essentially just really the list of total outcomes. So for example, if we have that a coin is flipped, then we write out the total possibilities for that, which would be that if it's flipped once, we would have that it could be heads or it could be tails. Now, if we have that a die is rolled, well, the possibilities are 1, 2, 3, 4, 5, and 6. But let's say, for example, that we wanted to look at maybe like if there's a child is born, perhaps, like we have that a so the possibilities would be that it could be a boy or a girl, assuming that there are no multiple births. So sample spaces is really just listing out the total possible outcomes. So for example, if we wanted to know like what is the possible outcomes, and we say that a coin is flipped two times. Well, to do this example, we would actually need to consider about, you know, what would happen if the first coin was a heads versus what if it was tails. So you could have, for example, that on the first toss, you have that it's heads. On the first toss, what if it was tails? But then, what if it was heads? So the outcome could be that you have heads heads or heads tails, or that you have tails heads heads tails tails. So what this does is it tells you that the sample space for the experiment with a coin tossed twice would be heads 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 tails tails heads, and then tails tails. But let's say that you're playing a game of paper, rock, scissors. Well, if you're playing a game of paper, rock, scissors, then let's say that you're playing with two people. So we just have to assume. Okay, so if that's the case, then the possibilities that you could have, for example, well, you could have that one person does paper, the other person does also paper. Another could be paper, rock, paper, scissors. But then you could also have, what if it's rock, 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 paper, rock, scissors, and then we have that the last the last examples could be that it's going to be scissors, 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 rock, and scissors, paper. Now, note that in this example, there are a total of 9 different outcomes. So you have that there's 3 possibilities for the first person, and then you have that there's 3 possibilities for the second person. So that means that there are a total of 9 possible outcomes. Okay, so this would tell us that, yeah, that we have that if we wanted to know the count of the sample space, then this is one way that we could do this. Now, our goal is to figure out, like, how to do a probability of any event. So when we look at the probability of an event, well, the probability of an event says that we can take the probability of any event that we call E, and that it has to be the count of the sample space, or not the sample space, but the count of the event divided by the count of the sample space. So what this means is that you have the number of ways for, we'll just say E, and then this is all divided by the total possible outcomes. Okay, so let's say that we wanted to look at an example where we demonstrate how we can find the probability of a specific experiment. So let's say that that a coin, so we're just going to say that a coin is flipped 3 times. Okay, so a coin is flipped 3 times. Now, I have a simple way to basically figure out like the total sample space as mentioned before, but let's just say that we want to find the probability. Find the probability the coin lands on heads, and we'll just say 2 times. Okay, so we have that. We just want to figure out like when it lands on heads 2 times. So to do this problem, we would actually need to either draw a tree diagram. So that was a tree diagram from earlier. So like if we do like this, and then we have like tails and heads. Well, on the first toss, you have that it could be heads and then tails. But then if you do it again, you have that it could be heads and then it could be tails. And then similarly heads and tails. So that gives us the first toss, second, third. But I can furthermore figure out, like, what if we had that the first toss was tails, followed by heads, tails, and so on. So we just need to do the same exact thing where we have tails, heads, heads, and then tails, heads, tails, and then finally the last tree branch will be heads and tails. So we're only looking for, in this example, where we have heads occurs twice. So basically that would be right here, and right there. But then we also have that it could be heads, tails, heads. And then we have that it could also be tails, heads, and heads. Now, note that that would be it in terms of the chain of outcomes or total outcomes, because notice that one possibility is that it could be heads, heads, or tails. This is a lot easier if we just think of it like, let's just identify one outcome, then from there just say, well, you also have that it could be heads, tails, heads, and then tails, heads, heads, which is the exact same thing. So that's a little easier in that case. Now, if we go about counting how many different outcomes there are, note that basically if you count from here, there, okay, so like 1, 2, 3, 4, 5, 6, 7, 8, you have that there's a total of 8 outcomes. So what that means is that the probability that the event lands on, or the coin lands on heads 2 times, so like the probability of 2 heads is equal to 3 out of 8. Okay, so that's how we would kind of do that. And notice that, yeah, it did take a while to just figure out that it was all based on the tree diagram. But if we go ahead and we move a little forward where we talk about like counting methods, then the probability is way easier in terms of like finding uh, the different outcomes for the event. Now, let's say that, for example, that we just want to talk a bit about a simple probability. So another type of probability that you might have is like if you have, um, you're just having a selection from like a bag or a box. So let's say like there are 3 green marbles, and then you have that there are 2 red marbles. And then let's say that there are, um, let's say that there's 4 yellow, and then what we can do here is just say that there's going to be 1, uh, let's see, uh, let's use blue. So 1 blue marble. Well, suppose that we want to find the probability of selecting at random a, let's just say a yellow marble. Then in this case, like if we want to find, if we're going to select just 1 marble, then that's actually not too bad because we just need to figure out how many total marbles are there. So we have that in solving this problem, we have the probability of a yellow is going to be equal to, well, we have that that's going to be 4. But if we count how many marbles that there are, there's actually 3 plus 2 plus 4 plus 1, which is going to be 10. So that tells us that that's going to reduce to 2/5. But if you do convert it to a decimal place or a decimal, that's going to be, let's see, that's going to be 0.4. Okay, so the answer is, and yeah, I just realized that we could have just converted it right away. So it's going to be 0.4. Now, the other thing of which that we just need to add in to this introduction to probability is that whenever you're talking about the probability of an event, you must have that the probability of any event is less than or equal to 0, but or greater than or equal to 0 and less than or equal to 1. So for that, like you must have that any probability distribution has to be that it's between 0 and 1. But then you also have that if you were going to add up the sum of all probabilities for a probability distribution experiment, then it has to add up to 1 no matter what. When we look at, say for example, more about probability distributions in further sections, you're going to see that, like for example, if you have the probability of heads is a half, and you have that the probability of tails is a half, well, this is a probability distribution because of the fact that it adds up to 1. So if the whole probability of all of the events within the experiment do not add up to 1, then it cannot qualify itself as a probability distribution. The other things of which that you would need to look at is for when you have that the probability of the event has to be determined by data. So this is actually what we call the empirical method of finding probabilities. So really that's just talking about a frequency, and that's divided by the sum of the frequencies. Let me just change this a little bit. And what's kind of interesting about this is that it's saying that basically that the probability cannot be done using a specific experiment, but it's just based on data. So for instance, if you were to look at the data based on the US Census, you can break it down. For instance, if you're looking at like income or unemployment or you know different age groups and the number of cars that they own, for instance. And in either case, usually this empirical data is usually obtained from something like a census, even. Um, so that's just another uh, way of finding a specific probability is based on data. And the nice thing is that there's a lot of data that's available, but you must be cautious in terms of like, what's the source.